In this video, we're going to walk through how to conduct a population variance hypothesis test for two different population variances. So we're going to be comparing sigma 1 squared and sigma 2 squared. And for our assumptions for this, we're going to assume that both of our populations are normally distributed and that samples are both random and independent. So to look at our basic table here, it looks a little bit different than tables we've seen in the past. That's because we only have the two columns now. So we're going to look at our first column on the left, is our hypothesis for our null hypothesis is going to be sigma 1 squared is equal to sigma 2 squared. And then our alternative is that sigma 1 squared does not equal sigma 2 squared. So this is going to be our two-tailed test. And the way that we're going to actually determine this is we're going to use a new test statistic, and that test statistic is going to be this F value. So we're going to call this an F test. And the F value is determined by dividing the larger sample variance by the smaller sample variance. So if we have S1 squared is greater than S2 squared, our test is going to be S1 squared divided by S2 squared. However, if S2 is larger, then we flip those around and do S2 squared divided by S1 squared. And then we reject our null hypothesis if our F value is greater than F of alpha over 2. For our other hypothesis test, we're just going to have the one-tailed test, and we're going to deal with our alternative hypothesis of sigma 1 squared is greater than sigma 2 squared. So again, if we need to flip this test around based off of which S1 or S2 squared is greater, we can do that and just flip whatever values are S1 and S2. So again, our test statistic is going to be F is equal to our S1 squared divided by our S2 squared. And this is making the assumption that S1 squared is greater than S2 squared. So again, if they're different and S2 is greater than S1, we can flip those around. And we have the same basic rejection region. We have F is greater than F of alpha, and this time instead of F of alpha over 2. And the F statistic, or the F test, is based off of our F distribution. And our F distribution is a little bit different than any distribution we've seen in the past. The closest that we have is the T distribution, where it's based off the number of degrees of freedom. But in this case, since we're dividing two standard deviations, we have our test based off of the number of degrees of freedom for both of those standard deviations. So F alpha and F alpha over 2 are based off of V1 and V2, where V1 is the numerator degrees of freedom, so the top of our fraction, and V2 is the denominator degrees of freedom, so the bottom of our fraction.